Last time we started our journey to solve this problem from AMC test 10A 2019, which was the 24th problem on the test. And we ended up solving for Vieta's formulas, which we thought would come in handy when solving the problem. But we can see that the polynomial here is a third degree polynomial or a cubic polynomial. And so it would be very nice if we can derive the same for a third degree polynomial. So we'll be starting off today with another example. And this time we have a third degree polynomial. So let R1, R2 and R3 be the roots of the polynomial 2x cubed minus x squared plus 2x minus 3 equals 0. Find the sum of roots r1 times r2 plus r2 times r3 plus r3 times r1 and r1, r2, r3 are the product of roots. So give this problem a try, and this problem will help us to find the Vieta's formula for the third degree polynomial. So I encourage you not to solve for the roots because they might be irrational. So let us try to find the sum, the product and all of that stuff directly. Alright, so r1, r2 and r3. First let us think about the polynomial. 2x cubed minus x squared plus 2x minus 13 is 0. Well, we don't like the 2 in front, so we'll factor that out, or we'll divide both the sides by 2. So the polynomial becomes this thing right over here, 13 by 2 equals 0. Nice, looks much better. And we'll be working with this polynomial. So r1, r2 and r3 are the roots of this polynomial, which means that if we put r1 in here, r2 in here and r3 in here, we'll get 0. What does that mean? That we can express this thing as this expression. So x minus r1 times x minus r2 times x minus r3. And notice, whenever we put the r1 here, both of those will be 0. Both of these expressions will be 0, and the equality will be preserved. Similarly, when we put r2 and r3, both the sides will become 0. Very nice. Now, as we did in the second degree polynomials, we will expand this. So on expanding, we can get, let me swap the sides. So first these two, x squared minus r1x minus r2x and plus r1 r2 times x minus r3, and this is equal to all of that stuff right over here. So that is x cubed minus half x squared plus x minus 13 halves. Now let us multiply this. So x cubed minus r1x squared minus r2x squared plus r1 r2x minus r3x squared and minus r1 r2, okay, plus r1 r3x, and I am just putting those terms with the similar power on the x downwards below each other. So negative r3, so that's r2 r3x. Negative r3 times positive r1 r2 is negative r1 r2 r3, and that is equal to this polynomial right here. Now let us factor something. So negative r1 plus r2 plus r3, and we'll factor that x squared term. Next we will be factoring that x out, so we are left with this minus r1 r2 and r3, and that is equal to this polynomial. So the same polynomial, x cubed minus half x squared plus x minus 13 halves. Now let us solve. Let us compare both the sides. X cube equals x cube. We don't want that. So this thing, negative r1 plus r2 plus r3 times x squared is equal to negative half x squared. Negative half x squared. We can divide both the sides by negative 1 and negative x squared. So we will be left with r1 plus r2 plus r3 is half. And we are done for the first half of the first 1/3 part of the question. Next, let us find, and let me turn the page here. So we were comparing the two sides, so r1 r2 plus r2 r3 plus r3 r1 times x equals, and let me see, okay, what was the x term here? So that was plus x, that equals x, just x. We can divide both the sides by x, and we are left with r1 r2 plus r2 r3 plus r3 r1 equals 1. We are done with the second part of the question already. Pretty nice. Next, let us solve for the roots, for the product of roots. So we were left with negative r1 r2 r3 somewhere here, negative r1 r2 r3, that equals negative 13 by 2, the constant terms. So negative r1 r2 r3, that equals negative 13 by 2. We can divide both the sides by negative 1. We are left with r1 r2 r3 equals 13 halves. And we are done for the third part of the question as well. So in general, if ax cube plus bx squared plus cx plus d equals 0 is a cubic polynomial, and r1 r2 and r3 are the roots of this polynomial, then the sum of roots r1 plus r2 plus r3, that would be the negative of the coefficient of x squared term over a, that is the coefficient of the x cube term, and what is r1 and the product of roots, that is r1 r2 plus r2 r3, and taken 2 at a time, the roots are taken 2 at a time, r3 r1, that should equal c by a, which is the coefficient of the x term divided by the coefficient of the x cube term. And third, negative or the product of roots r1 r2 r3, that would be negative of the constant term divided by a, or the coefficient of the x cube terms, and those are the Vieta's formula for a third degree polynomial, which I believe will come very handy when solving the original problem. Thank you.